Good afternoon, everyone. Let's just wait for another minute and then we will start. So, can someone confirm, are my slides visible and am I audible?
Yes, sir.
Okay, let's just begin then. So, we ended at this slide yesterday where we started talking about the formation of coal. We said that land plants, when they die and get buried very quickly in swampy area, that is where, due to burial pressure, heat, and with time, the plant material eventually form lignite, and with subsequent maturity, it forms subbituminous, bituminous, and anthracite rank of coal. So that's where we essentially stopped. We said that the anoxic environment is extremely important here, and that makes sure that the carbon bodies are not decomposed. We gave the examples of two areas. We compared the areas with Satpura's jungles and Sundarbans, and we discussed where do you find better potential of having coal. And we ended up saying that although Satpura jungles have a lot of wooden material, but then that would perhaps not be the ideal place for the formation of coal, simply because there would be limited chances by which shell can very quickly deposit it and then create an anoxic environment, isolate that pile of wood from the outside environment. And for that, you need a quick deposition of shell, and that is only possible when sea actually inundates into the land. And that we can observe in an area like Sundarban, like a swampy area, like a deltaic setting. So deltaic depositional environment, hence, is ideal for coal formation. We also said that most of the coal deposits around the world comes from Carboniferous and Permian, because that was the time for land plant boom in the history of geological time. And hence, most of the coals that we observe around the world, most of them come from that period of time. Of course, there are coals from other periods as well, which are pretty. I mean, for example, you have tertiary coals, as well as you have Jurassic coals, and so on and so forth. But then the main time period where coal actually formed was Carboniferous and Permian. So let's continue with the discussion. So coal normally gets produced in horizontal bands, and they are called seams. Okay, so this is important nomenclature that you should remember. We don't call coal. I mean, in sedimentary geology, uh, individual rock units are called beds, right? So you can call it a coal bed as well if it is a coaly layer, okay, coal bed. Some people call that too, but then you can also call it a coal seam. Okay, seam is a special name assigned for coal. Right? Coal seam. So thickness can range from few feet to hundreds of feet, overtopped by non-coal layers, which are called overburden. Okay, so that we explained yesterday that suppose I have a coaly layer. Suppose I have a coaly layer. Let's put the coal black. and then above which I have, layers of sandstone and shell. Okay. So, this could be somewhere, this could be any thickness. So this thickness, we will call it as overburden, of course. Okay. Now, the thickness of the overburden is very important. Okay, so this thickness of the overburden is very important. Why? Because this actually determines your mining strategy. Okay. Suppose if the thickness of the overburden is around say 20 to 50 meters, it's not very thick. Okay, it's thick. Then what you can do, you can altogether, remove this overburden. You can remove this overburden, okay, just by digging it out. Okay. And you can remove the overburden and you can mine the coal out. Okay. And this type of coal mining, we call it as open cast mining. This is open cast mining, where you completely remove the overburden from the above the coal seam and then dig out the coal. Right? That is called open cast mining. But compare that with a situation where I have a very thick overburden, which is maybe hundreds of meters, maybe 500 meters. This thickness, if it is say 500 meters, okay, and then if you have a coal seam which is lying beneath 500 meters, then you will not be able to. It will not be economical or almost impossible to actually remove the whole coal seam, right? So remove the whole overburden from it. Okay, so what do you do then? Then you dig underground mines. Okay, underground mines. So you prepare shafts, and then through shafts, we will talk about coal mining in detail later on. For the timing, remember, shafts are created, and then all must have experienced underground metros. So like that, such tunnels are being created inside the inside the earth, and then coal is taken out. So it all depends on the thickness of the overburden. If the thickness of the overburden is less, you go for open cast mining. If the thickness of the overburden is more, then you choose underground mining. Okay. So this thickness of overburden is very, very important in case of coal. So geological forces can cause coal seams to tilt over time. So ideally, any sedimentary rock, uh, coal seams also get deposited like horizontal beds or horizontal seams, and then due to deformation, they might get tilted, faulted, folded, whatnot. Okay? It might get deformed. Sometimes coal become exposed due to the surface due to erosion. So sometimes you can also, of course, observe coal seam in an exposure. And how does that happen? Because the top part of the overburden is actually eroded. Let's see some photographs. So this is a beautiful photograph where coal seam is exposed from Alaska. You can see. So these are non-coaly layers. Okay. From the look of it, I'm not too sure, but from the look of it, this looks like very fine grained sandstone. Okay, so these are non-coaly layer, and these black layers are of course coaly layers, and you can see that due to isostasy, this whole coal seam has actually is right now over a mountain. Okay, and then you can see between these two coal seams. So if this is coal seam A and this is coal seam B, between these two coal seam there is another non-coaly layer. Okay. So now, if you just look at this coal seam now, if I just, for example, if I do, you know, if I zoom at this coal seam and if I look at this coal seam closely, I might also find some, non-coaly streaks in between within the coal seam itself. Okay, some non-coaly streaks. Say, for example, some shelly layer or from sand or some sandy layer. So such non-coaly streaks within the coal seam, they are called partings. Okay? They are called partings. Okay. So what partings do? What is the contribution of parting? If I have more parting in the coal seam, that will essentially increase the ash content of the coal. Okay, ash content will be enhanced if I have more partings in the coal, right? So this is another example of coal. Another example of coal seam. You can see that this coal seam is slightly deformed as well. As you can see, this is a road cut section. So these, you can, by the look of it, you can see these are my non-coaly layers. This is coaly layer, and you can recognize the partings here if you look carefully. This is a layer of parting, you see. This is a layer of parting. Within that coal seam, it's a very small layer of non-coaly material. So this will be contributing to the ash content of the coal, right? Because you might be able to remove this non-coaly layer and this non-coaly layer while, I mean, all together while taking the coal out. But this is very difficult to remove physically. So they will be mixed with your coal and will contribute to the increment of the ash content, right? And you can also observe very beautiful sedimentary structure in a coal basin like this. Okay? You can see these are the development of beautiful channels. Because deltas, we said the coals generally form in delta sequences, right? So deltas often have such channel morphologies also preserved with them. When you study sedimentology, you will see more about them. Okay, this is another example, coals from Pennsylvania, and you can see this is a coal layer. By the look of it, you can identify. Also, you can see that this coal seam is actually faulted, right? So this is the hanging wall of the coal seam. The hanging wall. Sorry, my apologies. This is a normal fault. So this is a foot wall, and this is a hanging of the block. But you can see that the coal seam is actually faulted. Okay, here is another coal seam, of course. Okay, and these are non-coaly layers. So coal often contains the volatile matter. Yeah, volatile matter, and a major percentage of the volatile matter is nothing but hydrocarbon. Okay, so gaseous hydrocarbon, right? Like methane. Okay, CH4. So it is very easy to actually these volatile matter can actually catch fire pretty quickly, and you can see here that this coal which is kind of inside, perhaps in a mine, and then it has naturally caught fire, maybe due to high sunlight or so. And these can be fairly dangerous and pretty I mean accident prone stuff. Those I don't know if any one of you belong to the area of Jharkhand where there are coal mines, and they are very exposed to such coal fires. I mean, you can see such surface fires through faults and fractures on the ground where the thing is burning, and that is what we call as coal fire. Okay. and that's a pretty common phenomena and can be pretty dangerous as well. You can see, you can identify here also a pretty thick coal layer.
Okay, sir.
Yeah.
Sir, the CH4 that you said that caused the burning, it
Hmm.
is being trapped in the coal as a result of like by end product of the reaction or
Yes,
formation of coal.
that is true. That is absolutely true. It is actually trapped. I mean, you can the more what should I say? Technical term is adsorbed. It's adsorbed within the coal matrix. Okay, so if the coal is at a depth, you know, at a deeper, if it is buried at a depth, what happens that due to pressure, the it's more absorbed. But if you take it to the surface, you know what happens, the pressure gets released and the adsorbed volatile matter starts to come out more. Okay, and then it becomes more easier to catch fire on it. Okay, this is not only CH4, there are other hydrocarbons as well, volatile hydrocarbons that contains the volatile matter. Okay, but it's
And
trapped and it is formed due to the qualification process. Yes. Yeah.
sir, volatile hydrocarbons that you said, then they must be like small chains because long complex organic chains they can't catch fire as such.
Yes, that's right. The CH4 is a small chain only. Right. I mean, CH4 is pretty basic. I mean, CH4 is not a long chain that gets fired. So there are plenty of CH4 in coal. Okay.
Okay, sir. Yes, sir.
Okay. Now this is an important slide that actually classifies coal into different lithotypes. Okay. So as we said, if you look at a coal, I don't know if you remember looking at a coal from your childhood, but let me just show you a picture which I showed you before as well, and then we will discuss this coal lithotype once more. You know, when have any picture like that. Okay. So you can, what we discussed yesterday is you can actually observe that there are some very bright bands present in coal, very lustrous bright bands present in coal. Like in anthracite, you can see this whole thing is pretty bright. But then also in a bituminous coal, you can observe that it is divided into several bands. Some of the bands are pretty lustrous, and some of the bands are pretty dull. These are called bright bands, and the other ones are called dull bands. Okay, so that is one of the fundamental criteria to judge the lithotype of coal by looking at the distribution of the bright band and dull band. Okay, we will see why bright bands and dull bands actually occur in a moment. Okay, so we are essentially trying to um, subdivide the coal lithotype based on the frequency of the bright band. Okay, so you can see here from left to right, of course, the frequency of bright band is increasing. Okay, here maybe occasionally one bright band is occurring. You can see three bright bands occurred, and so on and so forth. The frequency of bright band is essentially increasing, right? And here it is so frequent that it almost looks like the whole thing is bright. Okay, so by um, by that particular nomenclature, okay, so we can call them, you know, dull band. So you can call the coal to be dull coal, where less than 1% bright band is present. Uh, then dull minor, you can call them, 1 to 10% of bright band present. Banded dull, 10 to 40% of bright band present. Banded, 40 to 60% of bright band present. And banded bright, we can call 60 to 90% of bright band present. And bright coal, where more than 90% of bright band present. Okay. And also, so this is what, this category we can also call them as non-banded coal, because the banding is not very well developed. These are non-banded. This is well banded, but this is also non-banded. Okay, but non-banded is the other side, right? This is perhaps your anthracite, right? This is your anthracite. This is perhaps your, this whole thing is perhaps your bituminous coal. This is the banded bituminous coal. Okay. Now there are two international organizations who actually provide different standards in coal classification. One we called as the ICCP, which is the International Committee for Coal and Organic Petrology, and the other one is ASTM, which is American Society for Testing and Materials. So they call this dull coal, they call as Duran. Both of them called Duran. Dial minor is also called Duran. The one with the banded dull is called Duroclaren by both of them. The banded one is called Claren by both of them. The banded bright is called Vitroclaren by ICCP, and the same coal is called bright Claren by ASTM. And then if it is completely bright, both of them call actually Vitrine. Okay. Now there are some other type of coals. There are like fibrous coals. Okay, it would have been better if we would have been looking at each other, face to face. Then I could have shown you some coal samples, which is also named as fusion, charcoal, or mother coal, shelly coal, or bone. Then coaly shell, there is something, carbonaceous mudstone, which is nothing but mudstone. It's mudstone, but then it has a lot of organic matter, almost looks like coal. That is what we call as coaly shell. Okay, and then the other type is called shelly coal. So there is a difference. Shelly coal, that means there is primarily it is coal, but that has some shelly content into it. So that is also what we call as fusion. Okay, and then coaly shell, which is primarily shell, but that has some coaly component into it. So these are the other categories. I mean, including the Duran, Claren, Duran, Duroclaren, Claren, Vitroclaren, and Vitren. We also have fusion and coaly shell. Okay? So these are the categories of coal that we find in nature. So you can look here at the picture of a coal stratigraphy, how beautiful the stratigraphy has developed. So say, for example, this person, maybe he has a height of how many? 5 feet. So this coal seam, you can imagine, is having a height of 5, 10, 15, 20, 25, yeah, around 30 feet thick coal seam, right? So this is around 30 feet thick. It's quite thick coal seam. Okay, so you can very quickly see the coaly layers, of course. So these are the coaly layers, but then also you can identify the partings. Okay, so I can identify parting 1, parting 2. There are some smaller partings as well here. Maybe this is parting 3, parting 4. These are the major partings that we observe here. There are also some intermediate partings. Okay? So these partings are actually very important indicators of the coal cycles, you know. So why they are important in terms of coal cycles? So we said, so while these partings were actually being deposited in that area, that means coal was not being deposited. Okay? Coal was not being deposited whenever those partings were being deposited. So those essentially mark maximum flooding surfaces. Okay? Why they mark maximum flooding surfaces? That is a discussion that is beyond the scope of this particular course. I will refer to your sedimentology class. If you are taking it already, you can discuss it with your teacher, with your instructor, or you can, if you have already taken it, you can think about it, why these partings actually represent maximum flooding surfaces. Okay, so it's like they represent, so each of these intervals represent major depositional cycles. Major depositional cycles means that, we talked about it, that coal essentially forms in a deltaic environment. So that deltaic environment occasionally gets inundated by sea. The sea essentially comes up to the land, and then again sea retreats back. So this, when the sea comes back to the land, a maximum flooding surface is generated. Okay, and the process is called translation, and then the sea retreats back to the to its original position, and that is what we call as regression, translation and regression. So one translation and regression actually forms a cycle. And depending on the translation and regression, the formation of whether parting will be formed or whether coal will be deposited actually is being decided, right? So by looking at a coal stratigraphy from top to bottom and marking the partings, you can actually identify these cycles. And if you have a means of actually dating those cycles by biostratigraphy, for example, by looking into the fossil content of the samples, you should be able to date those cycles as well. Okay. Now, so that's very important, and the such long, beautiful exposure of tall, beautiful exposure of coal, deposited coal, can actually give you a lot of information about the depositional cycles that is happening in that deltaic setting. Now, so now you can of course observe coal in a hand specimen. So you can see this is the scale of a hand specimen. This is 5 centimeter. So you are welcome to come by my lab anytime you want and observe different types of coals that you can when you are back to the campus. You can also we also have the luxury to look at them under a microscope. You can look at them under a microscope. Okay, it can be a simple petrological microscope, but the microscope has to be reflected light microscope. Okay? If you want to look at coal, you cannot look at them by transmitted light microscope. You have to have reflected light. Okay. And of course, you can look at them under scanning electron microscope as well. Okay? So you can see here, these are the pictures of, this is a hand specimen, of course. This is macroscopic. Yeah, so this is also a polished section. You are still looking at the in the hand specimen scale. Yeah, 50 millimeter scale. It's still the hand specimen scale, but it sample has been polished to see some features, and we will see what are they. But these are, of course, microscopic views of the coal. And now here, this is actually a core. This particular hand specimen is actually a core. You know what cores are from your petroleum geology class by now. It is actually built a cylindrical piece of rock, right? You can very well identify here this bright bands, right? These are my bright bands. You can see alternate bright bands and dull bands. Yeah. And this particular section that you are looking at here is actually cross section is actually a section which is cut perpendicular to the cylindrical axis. Okay, so that's the cross section of the cylinder. Okay? And the cross section is taken at a bright band. Just by the look of it, I can tell you. So you can observe another beautiful thing here, that this coal is, these bright bands are at least extremely fractured. They are filled with natural fractures, and they have a very consistent orientation as well. Okay? It's very consistent orientation and filled with natural fractures. Okay? I will come to the fractures in just a moment. You can also identify these fractures here. You see, this is the so the fractures are perpendicular to the bright bands. Okay, they are layer normal fractures. Okay? So here you are looking at the plan view of a or the cutting face of the fracture. You can observe the fractures here as well. You can see and you can identify two sets of fractures. Okay, one are pretty continuous, as you can see, and then there are some discontinuous. But the pattern is very consistent. Okay? The orientation is very consistent. Okay? So you can see here two sets of fractures. So in coal, in the bright band, generally in the bright band, you find two sets of natural fractures. Natural fractures. And coal fractures are called clits. Okay, coal fractures are called clits. The one set which is fairly continuous, okay, they are called face clit, and the one which are actually perpendicular or at a very high angle to the face clit, but somehow discontinuous, okay, they are called butt clit. Butt clits. Okay. And these clits are absolutely important for one particular thing, that these clits actually provide permeability to a coal seam. Okay? So the clits are important to provide permeability. These clits actually provide permeability to the coal seam. If these clits were not present in the coal seam would have been completely impermeable or extremely low permeability, because the matrix that we have in the coal seam, that is non-permeable at all. Okay? Now, we will come back to the clits in even more detail when we talk about coal bed methane. But you can also observe these beautiful fractures, the trace of these fractures in this microscopic photograph. And these are my face clits, perhaps. And this is where I see the different, and this is, and the next photographs, I can see different components of the coal matrix. So here I am looking at different components of coal matrix. Okay. Now you can identify that there are some parts of it, are completely black colored. Some part of it is like grayish, that forms like the ground mass. Okay, this part like forms the ground mass, and then there are some parts which are extremely bright. Yeah. Like that, you can find, so like you can see, observe some sort of banding here as well, and these blacks are like sporadically spread over the coal matrix. So the moral of the story is there are, so coal is not essentially homogeneous. So it contains several microscopic components. So now if I compare that to a rock, such components will be called minerals, right? If I compare, if I look at a thin section of a rock, then such components will be called minerals. But in here, such components, such microscopic components, okay, which are made of different material, and we will see what are they. So the microscopic components that form the assemblage of these different components that form coal are called macerals. So um, in case of rocks, we call them as minerals like pyroxene, plagioclase, um, quartz, feldspar, whatever you name them, hematite, magnetite, anything. They are the microscopic components or the components or the that forms the assemblage which we call in together rock. Similarly, the microscopic components which form the total assemblage of coal, we call them as macerals. Okay? And we will just see in detail about the macerals in the next slide. Okay? So the microscopic characterization and the microscopic components are called the macerals. So macerals are primarily of three types. Okay? First one is called vitrinite, the second one is called inertinite, and third one is called liptinite. Okay? So the matrix that we have been talking about, and you can see if you look at a coal under reflected light microscope, you will be able to find them out. Okay, so the grayish stuff which actually forms the overall matrix of the coal, the grayish stuff, that is what is my vitrinite. And you can look at it here denoted by the word V. Okay, and then these slightly blackish stuff inside, you know here also you can find them. Okay, these are called liptinites. And then this bright stuff, the very bright stuff, this is my inertinite. Now let's start with inertinite. Inertinite is the the part that forms the ash. Now, this is most of the inorganic part. So this is the product of, say for example, I have the plant material which is cellulose plus lignin. Some part of it is actually gets oxidized, okay, and that forms inertinite. And then within that white stuff also, you can find some very very bright white stuff. Some very very bright white stuff. They are also inertinites, but they are, so you can see this semi bright white stuff is the inertinite, that's uh, oxidized product of cellulose and lignin. Okay, that also forms the ash. Similarly, these and the very very bright within them itself are also inertinites. They are called inertinites, but they are like inorganic parts. Say, for example, I can find a pyrite crystal in coal. Okay, pyrite crystal in coal. That's completely inertinite. That comes from the partings that we have been discussing, right? So if you find them, that also comes as a very bright stuff within the reflected light microscope. So that forms my inertinite. Now, from the cellulose and lignin, by the humification and gelification, it forms huminite, and then increasing qualification process, this forms the vitrinite. This vitrinite is actually forms the bright bands. Okay, this actually forms the bright bands. So whenever I have a layer which is rich with vitrinite maceral, that will form my bright band. And then there are resins, waxes, algae, spore. Yeah, they are relatively resistant to fusinization process, and that is what we called liptinite. That those are preserved as liptinite. Okay, fusinization or oxidation is the same thing. It's like it's like making ash out of it. Okay, making ash out of it. So if a rock has a lot of fusinite rich layers, we call if sorry if a coal has a lot of fusinite rich layer, we call it a fusion rich. We call it a fusion band. So and then how do you identify fusion with hand specimen? If you put your hand there, it actually comes out and makes your hand dirty. If you take a piece of coal, you will find not all the part of the coal actually makes your hand dirty. If you touch the vitrinite, it will not come out to your hand. It will not make your hand dirty. It will not dust your hand. But then if you touch inertinite, it will not do it either. It is the fusinite, which is the sorry, it's the inertinite as well as the fusion actually, that actually comes out to your hand. The liptinite will not do that either. Okay? So these vitrinite, inertinite, and liptinite, they are present in different percentages in different coal, and they are primarily called macerals in a coal. Okay? So composition will control the source of hydrocarbon texture. The source of hydrocarbons texture will control the storage and permeability, all things being equal. Okay, we'll come to this point later on. But remember, this coal can also form this coal. Any coal can also be the source rock for hydrocarbon. Okay, coal can be coal can be the source rock for hydrocarbon, right? So depending on the type of maceral that is present in the source rock, the quality of the hydrocarbon, the quality of the source rock will also be determined. Right? Okay, so I will just stop here and see if you have any question for the time being. And then I will continue in the next class because I have to, this needs to be discussed in a single class. Let me see if you have any question. Anyone? Okay, so I can see now 1, 2, 3, 4, 5, 6, 7, 8 out of 33 being present. Let me just take a screenshot who are present. Who's the class representative for this course? Why Gaurav, so less students are present? Any problem?
Sir, but I handle SIP on I handle only if it is
Well, what is that?
batch.
Can you can you speak up more?
Sir,
Can you speak up, please?
in batch only. Sir.
If they are running to the
Hello, sir.
campus, they okay. Yes, so fifth year is returning to the campus today. That's why this number. Okay, understandable. But can you let your friends know that this is not acceptable? Okay, 10 students coming to the class is not acceptable. Okay, I'll excuse for today simply because students are coming back. That's a fair reason. But then if I continue seeing such low um, attendance rate, then I have to bring that up to the higher authorities and see. I mean, if you have a general problem, actual problem with respect to internet, then we have to figure it out as well. If not, then we have to see what we can do. All right. So, any question? What we discussed, Shivangi?
Yes, sir.
Any question do you have?
Sir, I have written in the chat box about the ash content.
So you have not got gone through the earlier video. Yesterday, last class, you were not present. That means, huh?
No, sir, I was not present.
Okay, and you have not also looked at the last class's video. No, right?
Yes, sir. No.
So then how I can't, I mean, you have to look through that. I have already explained what is hash content before. That's why I tell you that you have to come prepared in the class. You know, I put so much effort in teaching you and try my best bringing people from outside and everything. And if you don't take it seriously, what's the point? I mean, it's not about getting marks in the exam, right? You have to prepare, bring up a career for yourself after you are passed out from here. These are important stuff. I mean, I make not only me, everyone, all the faculties try their level best so that you learn everything. And when you are actually exposed to the outer world, you do justice to what you have learned. But if you take these things very casually, this is what happens. I feel disappointed extremely. Anyways, I will see you then on. I mean, I will upload a lecture tomorrow, or sorry, on Friday, and then I will see you on next Monday. Thank you.